Welcome to Concepts in Chemistry. In this talk, we will discuss how to prepare solution from stock solution. To start, what's a stock solution? A stock or standard solution is a solution in which you accurately know its concentration. You can make stock solutions in the chemistry laboratory or buy from chemical manufacturers. Once you have a stock solution, you can prepare solutions of lower concentration by diluting the concentrated stock solution. So, to summarize, a stock solution is a solution in which you accurately know its concentration. And you can get stock solutions by preparing them in the laboratory, or you can buy them from manufacturers. So, how then do you prepare a solution of lower concentration from a stock solution? You normally prepare a solution of lower concentration by diluting a stock solution. So, let's look at the concept of dilution. So, to dilute means to add a certain amount of solvent to a certain amount of concentrated stock solution. Okay. To concretely illustrate this, let's look at these particle models here. Now, as you can see, this is a beaker containing a certain amount of solvent. So we call this solution in this beaker concentrated solution. So let's assume that in this beaker we have 7 molecules of solute in 200 ml of water. Okay, so that is our concentrated solution. Now let's look at our dilute solution. So let's say we want to make a certain solution with a lower concentration than what we have here. So we then decide to add a certain amount of water. So we decide to add 200 ml of water. And in that case, the water level rose to a new level. So in this case, we have 400 ml of water in here. But I want you to pay attention to the number of molecules we have in here. So here in the concentrated solution, we had 7 molecules in 200 ml of water. Now in the dilute solution, we still have how many molecules? 7 molecules in 400 ml of water. So if you compare the concentrated solution to the dilute solution, the only thing that has changed between the two solutions is just the amount of water. Okay. So to dilute just means you add a certain amount of your solvent to a higher concentration solution. Okay, so to add a certain amount of solvent to a higher concentration of solution. So you just have to decide how much of the concentrated solution you need to take. You have to dilute it to the desired concentration you want. Okay, so once you understand that the moles, that is the amount of solute in the dilute and concentrated solution remains the same, then that means that we can write an expression equating the amount of solute in the concentrated solution to the amount of solute in the dilute solution. So this means that moles of solute in concentrated solution is equal to moles of solute in the dilute solution. And we are able to say this or write this because the amount of solute remains the same in the concentrated solution and the dilute solution. So once we understand this, then we cannot write a mathematical expression. So here we would then say the moles of concentrated solution equal to moles of dilute solution. So the next thing we now need to do is think about how do we calculate moles? Okay, what is the relationship between moles and the concentration and also the amount of your solution? So this leads us to this formula here. So usually we can calculate moles if we know the molarity of our solution and also the volume of our solution. Okay, so molarity is just a concentration. It's just a way of expressing concentration in moles per liter. So once we know the molarity and the volume of the concentration in liters, then that means that we can replace the moles in this expression with volume and molarity. Okay, so once we do that, then that means that we can rewrite the expression as volume of concentrated solution times molarity of concentrated solution is equal to volume of dilute solution times molarity of dilute solution. Okay, we're able to write this because moles of solute in concentrated solution is equal to moles of solute in dilute. And instead of saying moles again, we have just replaced moles with volume and then molarity. Okay, which of course is saying that moles is related to volume and molarity, and we can always find moles if we know the volume and the molarity of a solution. Okay, so we have just replaced moles with these variables. Okay, so once we have this expression, That means that if you know any three of these variables, you should be able to find the fourth one. You just have to apply a little bit of algebra. Okay. So let's go ahead and describe what each variable stands for. So the V con here, so the con here just means a short way of saying concentration. And the dal here just means a short way of saying dilute. So the volume of concentrated solution, which is V con, times the molarity of concentrated solution. Okay. And then is equal to the volume of dilute solution is equal to a molarity of dilute solution. Okay. So that is that. So this is the expression you need to know. Once you understand this expression, you can always use it to calculate the concentration of a dilute solution, or the volume of the dilute solution, or the volume of the concentrated solution. Okay, so yeah, so once you know this formula, it's very useful in solution preparation. Okay, so let's look at an example. So here, the question says, suppose that in one of your general chemistry experiments, you are required to use 2 molar sulfuric acid for a certain reaction, but your lab instructor gave you 5 molar sulfuric acid. How would you go about this? Okay. So just by reading the question, you have been given 2 variables. Okay, so based on the expression we talked about, you need to know at least 3 variables to find the fourth one. But based on this question, you only have 2 variables. So how are you going to use that formula to solve this problem? Now, if you read the question carefully, this is in the lab. So they gave you a certain concentration, which of course is 5 molar sulfuric acid, and you want 2 molar sulfuric acid. Since you are carrying out an experiment, it's up to you to decide how much sulfuric acid you need. So that means that once you decide how much sulfuric acid you need, then that means that you only have 1 variable to solve for. And this variable is just the volume of the concentrated solution you need to take out to prepare your desired 2 molar concentrated dilute solution. Okay, so that is all you need. That is all you need to do. Okay, so once you understand this, then we will then proceed to solve this problem. Okay. So let's go over the question again. So suppose that in one of your general chemistry experiments, you are required to use 2 molar sulfuric acid for a certain reaction, but your lab instructor gave you 5 molar sulfuric acid. How would you go about this? So as I pointed out, you need to know 3 of the variables in the dilution expression to be able to calculate for the fourth one. But based on this question, you're only given 2 variables, which means that you need to find the third one to enable you to calculate for the fourth one. So if you read the question carefully, you want 2 molar sulfuric acid solution, but you've been given 5 molar sulfuric acid concentrated solution. So this means that since you want 2 molar sulfuric acid solution, you have to decide how much of it you need. So which means that if we need 5 mils, then that means that we have now figured out the third variable. So we then proceed to find the fourth variable. So we write the expression again. So we say V con times molarity of concentrated solution is equal to volume of dilute times molarity of dilute. Okay? Yeah, so now volume of concentrated solution, we don't know. Okay? Molarity of concentrated solution, we know, which is 5 molar. Okay? Now, volume of dilute, we have decided that we want 5 milliliters. Okay? Then molarity of dilute is 2 molar. Okay? So yeah, so we now have the 3 variables, so we just need to find the volume of the concentrated solution we need to take out from the concentrated solution and then prepare our 2 molar dilute solution. So which means that let's solve for V count. So we say V count, since we don't know it, times 5 molar is equals to V dilute, which is 5 mils, times molarity of dilute, which is 2 molar. Okay, so clearly molar will cancel molar because they are on opposite sides of the equal sign. And also there's 5 here, there's 5 here, so 5 will cancel 5. So basically our volume of concentrated solution is equal to 2 mils. So we need to take 2 mils of our concentrated solution, put it in a flask, and then add 5 mils of water. That's all we need to do. But since you're dealing with sulfuric acid and water here, you have to be very careful, because sulfuric acid is denser than water. So if you put sulfuric acid first in your flask and then you now add your 5 moles of water, because sulfuric acid is denser than water, the water molecules wouldn't be able to go inside and intermingle with the sulfuric acid. It would rather create a barrier between the sulfuric acid and the water layer, and this barrier is unstable, and as a result it will generate loss of energy, which can cause explosion. Okay, so it's always good to put your water first. So in this case we put 5 mils of our water in our flask, and then we now add sulfuric acid to it. So we now add our 2 mils of sulfuric acid to our 5 mils of water. Okay, so as we're adding, because sulfuric acid is denser than water, it's going to go inside and intermingle well with the water molecules. Okay. Now, if you still want to add water to your sulfuric acid, then what you need to do is you need to maybe put your flask with the sulfuric acid in it in ice to kind of like cool it down while you're adding your water to the sulfuric acid. So that's an alternative way. Okay. Yeah, so that is it.